All right, so this is a bowling ball activity that we're going to be reviewing from the time we did this in class. This is one bowling ball and one student, and we took a picture of them many times as they were moving through the gym. And so this blue arrow right here is going to represent where the bowling ball was hit. So initially, the bowling ball was hit, and then the student repeatedly kept hitting the bowling ball at the same spot. And what you will notice is that the picture of the bowling ball gets further and further apart from each other. So this is going to be representative of something that is speeding up. All right, so each blue arrow represents a mallet hit. It doesn't represent velocity right now. It represents a mallet hit. And what we noticed is that the mallet hit was the same magnitude or size. So the same magnitude of mallet taps happened. And the taps in the same direction will will have the object increase its velocity. All right, so if the object is moving to the right and we hit the bowling ball going to the right, then the velocity of the bowling ball will increase. And that's what is shown here in this picture. So again, if you hit the ball in the same direction it's traveling, the velocity is going to increase. And now we have the bowling ball. It looks like that the bowling ball, when we took the series of pictures, it's going to the right. The bowling ball is getting closer and closer together. And so we're going to see how to hit the bowling ball so that it does get closer and closer together. So again, the bowling ball is traveling to the right. You can see that in the green arrow above the student. And so the bowling ball is getting hit in the opposite direction that it's traveling in. All right, so this blue arrow again represents the bowling ball where it was hit by the mallet. All right, so as we hit the bowling ball in the opposite direction that it's traveling, the picture is showing that the bowling ball is coming closer and closer together. So that means that's showing us that it is slowing down. Okay, so again, same magnitude or the same size of mallet taps. The same magnitude of mallet taps. That means we hit this bowling ball at the same amount of power or force is what you guys were saying in class. All right, so if you tap in the opposite direction that the bowling ball is traveling in, then it's going to have a decrease in velocity. Okay, so the object's velocity will decrease when it is hit from the opposite direction. All right, so now we're also going to be taking a look at a bowling ball that was hit once. And in this picture, you have two students who rolled the bowling ball across the floor. And so then there was one moment where it was hit, and that's at the beginning. Okay, so this blue arrow represents the push from one. Okay, so only one interaction or only one moment where it touched, and that would be at the beginning of this. Okay, so only one hit. So in this picture, it's the push. And in our class, it was a no touch zone when it did this. Okay. And so what we notice is that the same bowling ball that was taken a picture of many times, the distance between each picture of the bowling ball is showing that it's about the same. So that's going to tell us that it's the same speed. Kind of like when you did motion maps, you had the dots equally spaced out to show constant velocity. And so because the ball is going the same direction and there's the same amount of space between each picture, that's showing us a constant velocity. All right. And that is for something that was not hit. Okay, and so you should have done this part for homework, and we went over this in class, and you should be able to like draw the arrows if you forgot to do it for homework. And so just a quick review, right? We've got our green arrow here. Our green arrow is showing that that is our force arrows where the bowling ball was hit. And it's the same size, which is why I'm just copying and pasting my arrows. And it's going to show that the bowling ball that's moving to the right and it's hit to move to the right, then the bowling ball is going to speed up. And in this next photo, the bowling ball is also moving to the right, but now we're hitting it on the other side of where it's moving. So that's going to show that the bowling ball is going to slow down. Okay, so that's what the slowing down is going to look like. And for the constant speed, it's already moving. So at the beginning, we don't assume that it is coming in from rest. We're going to assume that's already moving. All right, so it is already moving. So then that means there's no hit in order for the ball to keep moving. All right, so now here's the summary. We did not do this in groups, obviously, so we're just going to go ahead and write it in our class kick. Okay, so the main thing that I want you to take away is that the forces do not cause motion. Okay, so when we hit the ball to make it speed up, when we hit the ball to make it slow down, and then when it was already moving, right, there was no forces that were on the ball that caused the motion. However, forces can cause a change in motion. And so I want you to be able to differentiate between these two statements. Forces cause change in motion and forces do not cause motion, okay? And then that's it.